Hello and welcome back to a Game Dev Engineer's Super Duper Study Sheet. Today, we are looking at common geometry problems. So this section actually spans 3 pages, which is huge. That's the longest section I think of this entire guide. And I'm not going to go over every single one because in many cases I linked to the proofs. So for example, this website, Geomalgorithms, is really good at describing some of this stuff. So I would recommend you read through the proofs if you need to. I'll try to go over the most common questions. So this one they're definitely going to ask you, right? How do you check if lines are parallel? How do you check if they're perpendicular? Well, to check if they're perpendicular, very simple, right? Just take the dot product. If it's 0, perpendicular. Boom. How do you check if they're parallel? Well, one way you could do it is you could check if the cross product is equal to the 0 vector. In that case, they're parallel. Okay, cool. So now this is the one that ruined my chances of certain company. So basically, to determine a point on a plane defined by A, B, C, D, what you have to do first, and I forgot this step, it's very important, is you have to understand that A, B, and C are the norm of the plane, but it's not the normalized norm. You have to normalize that norm first. So in order to do that, you have to derive n, the normalized norm. And in order to do that, you just take A, B, C, the vector, and then divide it by its magnitude. And so you get n, which is the normalized norm. And then, as you recall before, d is the distance when you have the normalized norm from the from the origin to a point on the plane. And so basically what we're just going to do is we're going to draw a vector from the origin to a point on the plane, and that point is going to be our point on the plane. So how do you do that? Well, basically, what you're going to do is you're going to say point plus the point is equal to the origin plus n multiplied by d. But you're going to notice that that d is not the d they provided us, because the d they provided us is not necessarily the d with a normalized norm. If your norm came pre-normalized, then that's literally all you have to do. But otherwise, what you're going to have to do is you're going to have to scale it like this. You're going to have to scale it by d old divided by n, or just the absolute value of so if it's the old d, then that's going to be proportional to the old n. So you're going to have to scale the old n before you divide it. And so basically that's why you need to get the new distance from the origin, because of course that's going to change if you just had to normalize your norm. Of course, this is why when you save planes in data, it's better to just normalize the norm, do that once, and then you don't have to worry about this nonsense process. But something to keep in mind if you want to pass your interview. Okay, from that point, to get a second point on the plane, I would say it's more complicated because what you're going to have to do is you're going to have to choose an x and confirm that basically for a given a it's not equal to 0, or a given b it's not equal to 0, and then you can just perform a simple calculation here where you can assume that the z is 0. And so basically you're creating an offset vector here where you could do the second point is equal to the first point plus an x, y, and a 0. And so to determine that y, if you know that a is not 0 and b is not 0, you could simply use this equation. If it happens that b is 0, then you can swap it out with c. So the equation is not that different. Okay, so to find a point in a triangle, this is an interesting question. But basically you have to determine if a point P is inside a triangle defined by points A, B, and C. And so I'm not going to explain that because the proof is a little complicated, but there is a link in the guide, and if you follow that link, it's explained. And I think this is a GOM thermal algorithm. Okay, so the next question, this one is very common, so I will explain it. They're going to say, hey, is a point above or below a plane? And the idea of if it's above or below, that kind of doesn't make a lot of sense. But you could say, like, okay, given 2 points, are they on the same side of a plane or not? This is the same question, basically. Okay, and so in order to do that, you just perform a dot product between the point and the normal of the plane. And that's it. And so basically, if that result is greater than 0, then the point is on one side of the plane. In particular, it's the side of the plane that the normal is pointing towards. Fun fact, if you will. The same approach applies for a point above a line. So if you have a line, you basically get 2 points from that line, call them C and B, and then you take the cross product of... So what I have here is C is the point, and then the line is A and B. And so what you do is you take C and another line on that plane, C and another point on that plane. You do the dot product of those guys, and then you cross that with Oh, sorry, you don't do the dot product. What am I saying? Let me just read my notes here because I made a mistake here. Oh, sorry. So you're finding the determinant of the 2D cross product. So basically what you want to do here is you're going to take the components of C. You're going to take the x component of C. You're going to take the x component of A, and you're going to take the difference of that, and then you're going to multiply that with B here. So I don't understand exactly why that would be different than the cross product. I think I might have written here. Oh, I see. So it's C minus A multiplied by B here, minus A minus B. Let me think about that. I'm sorry. I got a little bit confused by my notes here. Basically, AC is a line segment, and that's what I was confused by. I thought A was a line. No, A and C are points. So basically, if there's a point C and a line, a segment, which is defined by A and B, you just take AC, which is a segment, and you cross product that with AB. Okay, and so that's essentially the same idea. But keep in mind, one of those cross products, one of those segments, yeah, maybe I should draw this, but basically the idea here is that you take the point. So you have the you have the line. What the heck? You have the line, and then you've got this point. So you want to take this line, and then either a line to the point from one section, or you could do this line also, and then you do the cross product of those two, and that will tell you whether or not basically the point is on one side of the line or the other. It's the same idea basically. In both of them, you're just taking the determinant of the cross product. It's not very interesting, but it's an important formula. Okay, so let's continue. To check if a line is perpendicular to another line. Oh, sorry, no. You want to, given a line L, find another line perpendicular to the line L. So that is surprisingly complicated. Back in grade school, I don't know if you remember this, when you're doing like rise over run, on a 2D graph, it's actually pretty easy. You just take the negative reciprocal. In 3D, there isn't really a negative reciprocal, but there's something like it, and so that approach is what we could use here. So the idea here is you just want to basically invert one of the elements in order to get the negative reciprocal, okay? So if x and y are both non-zero, then you can just invert x or y. So in this case, I inverted x. If y and z are non-zero, then you can, invert y. And if x and z are non-zero, then sure, invert x. So that's kind of the idea. And if you take that line, z and negative x, that's going to add up to the negative reciprocal. And then you zero the last component so that it doesn't affect your calculation. So that is one way you could do it if you could find two non-zero elements. However, if you only have one element which is non-zero, then you can just take a different element and make it a 1, and then everything else could be zeros. And basically, we're looking at like basis vectors here, or the x, y, z, the transform, right, on in Unity or something, right? That famous blue, red, green contraption. So that process is not very complicated. You could just take just one of the other numbers, make it a 1, and everything else stays 0. All right. Then this is also something to consider for particularly for physics. If you're going to a job with physics, you're going to want to know this, the closest point approach for object collision, and this is explained here in the link. What's here? So given a point P in a plane with a normal N, find a line L that contains P and is parallel to the plane. So the way to do that is you want to find the closest point to P that lies on N, call it C, and then C minus P is going to give you a line, and that is perpendicular to N, so therefore it is parallel to the plane. So that's how you would find that line. I would highly recommend drawing this. I don't have room for diagrams for all these questions on the sheet, but if you just... The way that I study this sheet, by the way, in order to practice, is I just ask myself the question, and I try to figure it out geometrically with pen and paper. And if I can't do that, then I read the answer, and then I try again. So that's how I'd recommend testing yourself for this. The idea is not that you memorize the answer. If you need to work on paper for a little while, you should be able to get it. The point is just that you can get it over a period of time, right? If somebody says to you, hey, given a point and a plane with normal n, find the distance between them, and, given half an hour, you can't figure that out. Given 5 minutes, you can't figure that out. You're in a bad situation, right? So that's where you want to practice. So here I got a diagram. Basically, the idea here is that we know the distance between P and a plane is going to be along the plane's normal. The fastest way between any 2 points is a line, right? Assuming there isn't a black hole or something. So that line, that straight line, is going to be the plane's normal. And so in the case of a P and the normal, all you need to do is project any point from the plane. You can create a line called YP, where Y is any point on the plane and P is the point you want, right? And so you take YP and you just project that onto the normal, and that will give you the distance. So it's actually that simple. And how do you find Y, right? That's the big question, and that's what I failed on my interview. But the answer is, how do you find a point on a plane? You do this formula, right? So that's where a lot of these guys kind of work together. So try that one. Give yourself that quiz. It's a tough question. It is. Okay, next. Find the distance between L and point P. Okay, so to find the distance between a point and a line, it's kind of similar. We're going to, again, use a projection here. And then here's the diagram that explains how to do it. So basically, you let L be defined as the start point and the direction vector, SD. So you want to calculate SP, which is going to be, a line from the point to some point on the line. And then you're going to normalize that line. You're going to normalize the line you want to project onto, and then you want to project SP onto SN. So I almost always normalize the line I'm projecting onto before I project onto it. And the reason why I do that is because I want to simplify this equation, which we talked about in the dot product section. But basically, if you have B, which is normalized, then the equation is much simpler. It looks like this. So I would just do that whenever possible. And so when I'm writing code, I almost always do that. Okay, cool. So let's check out this section. So the line, dist line. So given lines P and Q, how far apart are they? That is not an easy question. It's pretty hard, as you can see here, and I linked to the proof, so I'm not going to explain it. But I'll explain the key idea. So if you've got two lines, if you've got a line, what's the shortest distance between that line and a point? It's going to be a straight line. So if you've got two lines, what's the shortest distance between them? It's going to be a straight line between the two. And so that's actually the crux of the entire answer. Because if you can find a line which is perpendicular to both of the lines, then that line is the shortest distance. If you think about it, if you take any 2 points on two non-collinear lines, any 2 points, right? You're going to form a line that's not perpendicular to both of the lines unless it's the shortest distance. And so that's essentially what you're finding here, WC. And the way that you do it, it's explained in the formula, but basically you just plug it in, depending on, you just create this equation where you're setting it equal to 0 because you're trying to find, the dot product. When it's equal to 0, they're perpendicular. And then you're solving this for two equations to find when it's perpendicular to this line and when it's perpendicular to that line. Simple enough. Okay, cool. So then the next thing here is given two lines, find if they intersect. If so, where? And so this answer is, so this is a really good textbook, Computer Graphics Principles and Practice, 3rd edition. And in section 7.72, it's actually explained. But I will explain it to you after this short break. Sorry, I'm getting a little tired. I think I'm going to end this video here. But just to summarize the end section here. So basically, yes, if you want to find a line of the plane and determine their intersection, what you're going to want to do is define the plane with the normal implicit form. So that's what we mentioned before, where basically you just have the offset and then the normal. And so basically what this is saying is, this is the normal implicit form. Okay, it's kind of like a formula where x is the input and q is a point on the plane. And so what this is saying is, if you put an input point into the x here, that x minus the q times the normal is going to always equal 0. And so that's the normal implicit form. And so it's useful for problems like this, because what you could do then is you could take a point as, expressed from the line formula, and you just take this and you plug it in for x. So that's essentially what just happened here. And then you can solve. And you'll see that this expression, it does have a divide by a value here, which could be 0. But that denominator is only going to be 0 when the line is parallel to the plane. And so that's why we have this additional step in the beginning, which is where you dot product the line's direction vector with the plane's normal. And if it's 0, then if it's 0, then the plane. Then the plane and the line are parallel, right? So you just got to add that extra step so that you're safe for a divide by 0 there. So plane intersect plane is described here in great detail, so you can check it out there. Circle circle overlap. I got another link here. So what is this? This is Wolfram Alpha. So I will say though that this is very common actually in game development, so I want to address it. But they're gonna ask you like, hey, this is essentially the long version of the formula, right? Where you do x, you take their centers, you take the center x of one minus the center x of the second one, and plus the y-x of the one minus the y-x of the other one. This is almost never used actually in actual game development. You're always referencing the distance squared, and so you just want to see whether or not the distance squared is less than the sum of the radii squared. And the reason why is because the square root operation is pretty expensive computationally, and so it's always better to just square this value essentially, so the square root goes away, and you could just compare that against the sum of the radii squared, and that is functionally equivalent to actually finding the true square root, the true distance, because you don't really need the distance if you want to check for overlap. All you really need is to check if the distance is less than the radii sum. And so to sum, to take the square of the radii sum and compare that to the distance squared is functionally equivalent. So that's a really common optimization that you need to know. The other thing is that AA overlap with a axis aligned bounding box overlap with another axis aligned bounding box. How do you do that? Well, here's the formula. So if you have any questions, just leave me a comment and I'll help you out. The next section is the OBB overlap. Man, I'm getting very tired. And so that is expressed in this link, so they'll go into great detail. Basically, you're projecting a line onto every normal of both shapes. So it's expressed here, but there's some beautiful diagrams in this link in case you're confused. And okay, last thing here, which is how to create a coordinate basis given a forward vector and a world space up. Okay, so this is a question. This is pretty much a question I got in an interview once, and I completely failed it. So you're gonna want to know how to do this. So to create a coordinate basis with a forward vector, that's the local forward vector in the world space up, which is simply the world space up. If y is pointing up on your axis is 0, 1, 0. Okay, so I mean, given the world space up, that's not very helpful. It's just 0, 1, 0. But the forward vector, that is useful. And so if you want to create a coordinate basis given that forward vector, how do you do that? Well, your forward vector is essentially one column of the 3 by 3. So do the cross product with the forward vector and the world space up, and that will give you a local right vector, which is the r. So keep in mind that the r is not the world space right left. That is simply 0, 1, 0 or 0, negative 1, 0. The last step is you need to take the r and the f's cross product, and that will give you the local up down, which you could call u. And then fur is our new basis. So basically, given just the forward and the world space, up, sideways, and inward, you can create an orthonormal basis. And so that's how you do it. Ta-da! All right, so that concludes the longest video in this section. It certainly killed me. I'm about to fall asleep here. 4:30 on a Tuesday. But if this guide helps you, please leave it a like. Leave me a comment if there's a question you have. I'd be happy to help you. I'm always trying to refresh my memory on this stuff. And, the truth is a lot of these problems that we went through in this video, I need to work on them. I need to keep practicing them because my recall for all of them is not, as quick as it needs to be. So this is definitely the part that I'm working on the most because I don't think my math is as strong as some of my coworkers, And so that's something I'm always trying to work on, always trying to hone that skill, if you will. So if you're here to learn math with me, if you think there's an interesting interview question you got that's related to math, please let me know because I'm always looking to, practice that. It's something I really want to be good at. Okay, so join me in the next video where we talk about rotations, matrices, very related, and then we talk about this guy. So I can actually talk about this guy right now. This is a transformation matrix, right? So in Unity, for example, you've got this transform component, which is shown to you as a 3x3, right, with position, rotation, and scale. However, pretty much always in code, that's going to be represented by a 4x4, where you have the rotation and scaling represented by this 3x3. Then you have a 0 vector coming down this column here. A 1 by this is just a 1. That's a 1 by 1. It's just placeholder. And then you have your translation represented down here. Now, a bit of an interesting question I have is, okay, if they're using a 4x4 to represent their transforms, how are they storing quaternion data, right? Because they're not, they're not storing their rotations as 3x3s, are they? I would think that they're using quaternions, but that is not an answer. That is not a question I have an answer to. So that's something I'm still trying to figure out. So if you know, let me know, because I've been pondering that one for a few days, and I haven't quite figured it yet. But if you have an idea, please let me know. I'm trying to figure that one out myself. All right. Well, good luck on your interview, and hope this helps. Again, as always, if you get a question that stumps you, let me know, and I'd be happy to help you through it.